Hello, it's Chris here. Next few videos I'm going to post are going to be an introduction to some of the subjects, topics you might see early on in an A-level course. If you're thinking about doing A-level maths, watching these videos might help you decide if you want to have a go. Okay, today's one is going to be on partial fractions. So let me describe what partial fractions are all about. This is rather like when you were doing GCSE maths, some of the algebra you learned to start with kind of had uses later down for problem solving. And this is a bit like with partial fractions. We will find partial fractions particularly useful later on in A-level if you're doing some calculus. You'll find out the joys of calculus later. But just believe me that this is something that's useful later on down the line. So, what we're going to do is we're going to split x plus 1 over x squared minus 3 plus 2 into two parts, partial fractions. And the question in the exam paper would say something like, write what we have there, that x plus 1 over, in the form a over something plus b over something. And we're going to come back to that example in just a moment. I'm just going to show you how it might work without algebra, with separate numbers first, just so you get the hang of it. So, what do we do if we're adding fractions together? Answer, we make sure the two bottom numbers are the same. Now, you'd look for the lowest common multiple if you're doing fractions, or actually it doesn't have to be the lowest, it just has to be a common multiple. It's standard when you're using sort of numbers to look for the lowest one, but for the sake of what we're doing now, just has to be any common multiple, which you can get by multiplying the two denominators together. Just so happens in this case it is the lowest, but when we do the fractions in a minute, it's a bit difficult to consider the term lowest. We're just looking for a common denominator. So how do we turn a over 3 into something over 12? Well, we multiply the top and bottom by the same thing. We multiply the bottom by 4. So we're going to multiply the top by 4. So that becomes 4a over 12. And this one, we multiplied the 4 by 3. So we have to multiply the top by 3. So we get 3b equals over 12. And then we join those two together, if we can do that. Normally I'd go straight to this step, but I think step by step because it's new. So then we're just comparing 7 over 12 with 4a plus 3b over 12. Well, the bottoms are the same. We just want to make these two things the same. So we can say that 4a plus 3b equals 7. We've only got one equation. Actually, there's lots of solutions to this, because we'll find out when we get on to the algebra one. At the moment it'll be restricted, but in this case there's lots of, it's a fairly obvious solution of a equals 1 and b equals 1, because then 4 plus 3 equals 7. But actually you could play around with these and have different solutions. For example, I'm going to do this. if b were 2, then that's a would be a quarter, and actually that would work too. Anyway, we won't worry about that too much at the moment. 1 and 1 is a perfectly decent solution. So we're going to go back and do the algebra one now. You may have already noticed, or you're going to notice now, that actually if we factorize the bottom part, that does come out as x minus 1, x minus 2. Let's just check that. x squared minus 1x minus 2x minus 3x, and then minus 1 times minus 2 is 2. So that is just, these two are just factorizing there. Okay, so that's sensible, because now, as I said earlier, when you're doing these partial fractions, it's a bit of a backwards and forwards process. So we're being told we want it in this format. So we kind of go backwards. Now, rather like that 3 and 4 in the last, in the number example, we're going to make the bottom x minus 1, x minus 2, which we can see over here is the same as what we've got there, x squared minus 3x plus 2. So, how do we make the a over x minus 1 to be part of this fraction? Answer, we multiply the top and bottom by the same thing, x minus 2. So, a x minus 2. Actually, what I'm going to do is I'm going to do what I did, and I'm keeping them separate for the time being, because then we can just see exactly what we're doing. So this, what we've done here, is multiply the top and bottom by x minus 2, and we can cancel those two things out, and we go back to the a over x minus 1 that we've got there. So we do the same thing with this one, but this one is b x minus 1 over x minus 1, x minus 2. Right. Now, I'm going to introduce a new symbol at this point. This symbol here is an equality. What that means is, with 3 lines, it means that for all values of x, that is the same as that. Because all we're doing is manipulating the algebra. We're not actually adding anything or taking away. So we can use that equal. That means that is more than equal, which is an identity. You'll get used to seeing that identity in A-level maths. That's the identity symbol. Okay, so now what I'm going to do is I'm going to multiply top and bottom out. So we've got ax minus 2a plus bx minus b. I'll just multiply the top and bottom brackets out. And now on the bottom, I'm going to multiply these two together just so they look like what's up there. It's still the same thing. I'm just repeating what I did there. So 3x plus 2. Okay, now we're going to say that is the same as x plus 1 over x squared minus 3 plus 2. We still don't know what values a and b are. I mean, we've been told that there are values a and b in the question. So we're just going to find out what those values are. Now the bottoms are the same. So rather like in the first one, I'm going to make the top equal the two tops equal the same, be the same. So x plus 1 has got to equal, and now let's gather together the x terms. So that's a plus b x, and then we've got minus 2a and minus so it's minus 2a and minus b. So I'm kind of doing a bit of factorising here. I've got a minus, if I put the next bit in brackets, 2a plus b, that minus is sort of spread over the bracket, so we end up with minus 2a minus b. Okay, so now we compare the two parts, and we find out that the coefficient, which is a number with in front of the letter in these equations, the coefficient of x is 1 on this side, so it must be 1 on this side. So we find out that a plus b equals 1. And then we know that because we've been told that this is the same as this, so we know that the coefficient of, well, the constant part of the equation, it minus 2a plus b, all in brackets, that equals 1, because the constant on that side is 1. So now what we've got ourselves is two simultaneous equations. I've not written them in the best form there. I've written them the form that shows that they come directly out of this statement. But to solve them, it would help us if we actually maybe I shouldn't have bothered gathering together before. I probably made extra work for myself here, but wanted to show you all the steps. So now minus 2a minus b equals 1, because we know that those two bits together have got to be the constant value there. So two simultaneous equations, and by writing them like that, I can see that I just can add these two equations together. A plus minus 2a, which is minus a. The b and the minus b cancel out, and the a, 1 and 1 is 2. So a, if I just multiply that, switch the minus sign around there, is minus 2. And then we can use this equation here, a plus something equals 1, well, a minus 2. So minus 2 plus something equals 1. So b equals 3. And then I'm just going to check my way with the simultaneous equations. I check. So that one there becomes minus 2 times minus 2 plus 3 equals 1, which is true. Sorry, that's that should be a minus sign there. Apologies. Minus 2 times minus 2 is 4. Take away 3 is 1. So we checked it. So A is minus 2 and B is 3. And we're there now, really. We can actually just replace that with minus 2 and replace that with 3. I'll be honest with you and say I normally write these round the other way around. I normally write the positive bit first. So even though, because A's and B's, A's turned out to be negative and B's turned out to be positive, I would actually normally write it like I've got in one of these screens here. Yes, here. Let me just, didn't want that bit just yet. Hang on, just gave you the wrong bit. Yeah, sorry, I did want that bit there, sorry. So I've switched these two round here. So 3 over x minus 2, take away 2, which is this bit here, over x minus 1. I've made a and b to be 3 and the minus 2 that we found out in the working out on the other page. So there we have it, x plus 1 over that polynomial equals, in all cases, it's an identity, 3 over x minus 2, 2 over x minus 1. That's the answer to the question. And if you're in an exam and you're a bit short on time, you might want to leave it like that. But anybody who watched my videos before knows I always like to check these things with numbers if I can. So what I'm going to do now is I'm going to say, it's a nice easy number to put in there, let's say 3. Let's just check what happens when x equals 3. X equals 3, that means the top there is 4. Let's work this out. I can do it in 2 ways. 9, which is x squared, take away 3 times x. I've got x equals 3, so that's 9. It's easy enough. 2. So that works out. When x is 3, the numerator is 4, the denominator is 2, and that equals 2. So this side should also be 2. 3 over that x minus 1 is 3 take away 2, which is 1. 3 over 1 take away, and that is 3 take away 1, which is 2. 2 over 2, which is 3 take away 1, which equals 2. So I like doing my checks, so I thought I'd do a little check there. Okay, so that's it really, that is partial fractions. It's a fairly simple example. You might see some more complicated examples, but the start of the flavour of what doing partial fractions is about. That's it. Okay, so we've rewritten, going back to, we've rewritten x plus 1 over that quadratic to be minus 2 over that plus 3 over that. Partial fractions. Thank you for your interest in my video.